All right, I want to give you some help on this test coming up, and this is the review sheet that you will need to prepare for Chapter 9 and then just one lesson from Chapter 6. So let's get started. For number 1, we're finding the values of all 6 trig functions of angle theta in this right triangle. The missing piece that we need before we can find those 6 trig functions is this bottom leg. And so we know that if we have a missing side, if we know 2 of the sides of a right triangle and we're trying to find one of the third missing side, then we're going to use the Pythagorean theorem, and that says the hypotenuse squared, which in this case the hypotenuse is the 8, the side that measures 8, equals leg squared plus leg squared. I'm just going to call this missing leg B. And now we're going to subtract 25 from 64. So 64, that's 8 squared, minus 25, and that's 39. That's B squared. And then to find B, I have to do the square root of that. And if I could simplify that radical, that would need to be done, but I can't simplify the square root of 39. So now I've got all of my side measurements, and I'm going to walk through the 6 trig functions of angle theta, which is this bottom right corner. All right, so you got to know SOHCAHTOA. Don't forget that. Sine is opposite. So for theta, the opposite side is the one that measures 5. And then the hypotenuse, sine is opposite over hypotenuse. So that's the fraction 5 over 8, opposite over hypotenuse. Cosine is adjacent over hypotenuse. So the adjacent side of theta is the one that measures root 39 over 8. And then tangent of theta is opposite over adjacent. And here's an example of when we need to rationalize the denominator. You don't want to leave that radical in the denominator, so you just use that radical, multiply by the top and the bottom of the fraction, and you end up with 5 root 39 over 39. And now we'll take care of the reciprocal. So sine's reciprocal is called cosecant. So I just take sine and flip it over. Cosine's reciprocal is called secant. So I do the same thing. You can either take 8 over 39 and flip it. Okay. So let's just go ahead and do that. 8 over the square root of 39. And here we are again having to rationalize. So let me see if I can squeeze that in. I'm just rationalizing the denominator. So that becomes 8 root 39 over 39. That's secant. Okay, guess I could be circling these. And then tangent's reciprocal is cotangent. And I think the easy thing to do, instead of trying to take this, which you could take this and flip it over, I would just take this version and just do the square root of 39 over 5. And there's the answer for number 1. All right, so for number 2, we have a right triangle, and we're told that the angles A and B are acute. That just means that A and B are not the right angles, obviously. So I'll just say A is up here, B is down here. They tell us that tangent of angle A, well, we know that tangent is always the opposite side over the adjacent side. So for angle A, the opposite side would be this one down here. So I'm going to call this one 5. And the adjacent side would be the one over here on the side. And I'm going to call that 3. So we're kind of back to where we were in problem number 1. We have to find a missing side given 2 of the sides. and we happen to be missing the hypotenuse. So don't forget, when you're using the Pythagorean theorem, it really reads as hypotenuse squared is equal to leg squared plus leg squared. So c squared is, this would be 9 plus 25, that's 34. So c is the square root of 34, that's the hypotenuse. And now I'm ready to find, I already know tangent, so I don't have to list that. So I'm going to list all the other 5 for angle A. So I'm going to do sine of angle A. Sine is opposite, which is 5, over hypotenuse, which is root 34. And here I am again having to rationalize. So that's 5 root 34 over 34. Cosine of angle A is adjacent, which is 3 over the hypotenuse, rationalized. And that's going to be 3 root 34 over 34. We already know tangents, so we don't have to list that one again. So now I'm just going to work on the reciprocals. So sine's reciprocal is called cosecant. And I would just take this where we started off with 5 over root 34. Just flip that over. Root 34 over 5. Cosine's reciprocal is secant. And kind of the same thing, I'm going to take this 3 over root 34 and flip it. And tangent's reciprocal is called cotangent, and that's easy enough. We just take 5/3 and we flip it over and we got 3/5. So there's your final answer for number 2. All right, so for number 3, I'm trying to find this unknown, this side labeled as x. So looking from the 45 angle perspective, from that 45 degree angle, I'm given the opposite side of that angle and I'm trying to find the hypotenuse. So again, you got to think of SOHCAHTOA. You're gonna be choosing on this problem from one of the 3 primary trig functions, either sine, cosine, or tangent. Okay, so just think about from the 45 degree angle, given the opposite, and then trying to find hypotenuse. Well, you're going to be using the sine function for angle 45 degrees. All right, so sine 45 is the opposite side, which is 10, divided by the hypotenuse, which we don't know yet. All right, and now I would technically, the moves would be to multiply by x and divide by sine 45, but that's basically going to cause those to switch places. So you could just think of x and sine 45 switching places. So now we'll go to our calculator and we'll do 10 divided by, hit the sine button, and then put 45 in parentheses. And to the nearest tenth, that's going to be 14.1. So x is 14.1 units. We don't know what those units are. Okay, number 4. This time we're trying to find an angle. So let's see what we're given. We're given the opposite side of that angle, and we're also given the adjacent side of that angle. So once again, think of SOHCAHTOA. Opposite and adjacent. That's involved in the tangent ratio. So that's the ratio that I'm going to use to solve this problem. Tangent for some angle called x, and then make the opposite over adjacent ratio. Now, when you're trying to find angles, this is when you have to do second sine, cosine, or tangent. In this case, it's going to be second tangent on your calculator. So anytime you're trying to find an angle measurement, you're going to have to do, we call this inverse sine, cosine, or tangent. You hit the second button on your calculator and then the trig function. And you'll see it appear on your calculator with this inverse symbol, this -1. It means the inverse of tangent. And then you type in 27 divided by 18, close parentheses, and 56.309. So to the nearest tenth, we would say 56.3 degrees. Moving on to number 5, we're trying to find the height of a building. It's called D here in this problem. So we're looking from the 76-degree angle. You always want to look from the angle that you're given. So I'm looking for the opposite side. I'm given the adjacent side of that angle. So once again, that's what tangent refers to. Tangent is opposite over adjacent. So I'm going to use the tangent function for 76 degrees, and then I'm going to make the ratio opposite over adjacent. And then to solve for D, I'm going to multiply by 200 on both sides. And we'll go to our calculator and type in 200, tan, and then put 76 in parentheses. And this is to the nearest foot, so whole number. So it's 802.1561. So to the nearest foot, we would just say 802 feet. All right, the next one. Bookshelf hangs on a wall to the nearest degree. What is the measurement of angle L? Okay, here's angle L. So looking from angle L's point of view, we're given the opposite side of angle L, and we're also given the adjacent side. Well, here we are again using tangent. Tangent for angle L is the opposite side divided by the adjacent side. And since we're trying to find an angle measurement, this is when we have to do second tan. So we'll go to our calculator and do second button, tangent, and then 5 divided by 8 in parentheses. And let's see, to the nearest degree. So it's 32.0053. So to the nearest degree, we would just say it's 32 degrees. So to the nearest degree means no decimal places. It would just be a whole number, a rounded whole number. All right. Now we're going to be utilizing the unit circle, and I'm going to grab a unit circle to put on this. You'll have one. I'm going to give you a blank unit circle that you can write on, fill out as much of it as you need. You don't have to feel like you got to fill out the whole thing, but it'll be used kind of like a scratch paper to answer these problems. So I'm going to put this on pause, and I'm going to grab a unit circle like we had in your notes so I can look at it with you. Okay, so I've got a unit circle pulled up, and I'll just flip back and forth so we can take a look at it together. Your ability to fill out the unit circle and use it will be very key to answering these 8 problems on your test. So for number 7, I would always look at these improper fractions in terms of mixed numbers. So if you're not sure how that's done, I'm just going to take the bottom number and divide it into the top. So 3 would divide into 7 2 times, and there would be 1 left over. So that would be 2 1/3 pi. Okay, so 2 1/3 pi. And we're looking for the sine function. So remember, when you find this angle and you look at the ordered pair where that angle hits the unit circle, it's always true that cosine is the x coordinate and sine is the y. So really, if you know how to look these angles up, if you know how to make the unit circle, first of all, you look these angles up, and then it's pretty easy. You just have to know whether to look for the x or the y. And then if we do make tangent, which we will be making that, I'll show you how you can come up with tangent. in just a bit. So 2 1/3 pi. So let's go to our unit circle. And let me get that pulled up for us. Stay. I'll go this way. Okay. So if you were drawing 2 1/3 pi, well, you would just take your pencil eraser and trace out. This would be 2 pi. I just made a circle. And then 1/3 more would take me right here. Okay, I'm looking. This is another, when you see pi over 3, that's like saying 1/3 pi. All right, so I just sketched out 2 1/3 pi. I landed at this angle. I'm looking at this ordered pair. And again, because it's asking for sine, I'm looking at the y coordinate. And so my answer here is going to be the square root of 3 over 2. So that's my answer for number 7. All right, let me erase this. Get kind of messy if I don't erase as we go. All right, let's take a look at our next one. Cosine negative 60. Well, cosine will be the x-coordinate for the angle negative 60 degrees. Okay, so when I'm drawing negative 60, I'm going to start here. This would be the initial side, always. And when I'm drawing negative 60 degrees, it would be going down here. And this would be the angle. Now in the unit circle, it's going to show 300 degrees. But remember, the unit circle is always made in terms of positive angles. So we have to know how these negative angles would be drawn. So this would be negative 60. And we're looking at cosine, so we look at the x-coordinate of that ordered pair. And pretty easy, our answer is going to be 1/2. Okay, so now we're going to go to cosine 450. So let's look at how 450 degrees would be drawn if we were doing this. All right, so if I'm drawing 450 degrees, that's 360. So a circle. And then I need another 90. So if you did 450, that would be 360. If you wanted to on your calculator, you could do 450 minus 360. And so we need an extra 90 degrees. So that would be 450 degrees. And since we're looking at cosine, remember cosine is the x-coordinate. We just look at the x-coordinate at that angle, and that's our answer. So our answer is 0. All right, here we are again with, this is in radians and it's an improper fraction. So you might want to consider thinking of it as a mixed number. Just divide 4 into 11. 4 goes into 11 2 times. 2 times 4 is 8. 3 left over. So instead of 11 pi over 4, let's think of it in terms of 2 3/4 pi. And sine means we're going to be looking at the y coordinate. All right, so let me erase my other one. And we're going to do 2 pi, which is another way of saying a circle. All the way around the circle is 2 pi. All right, so 2 pi. And then I believe it said 3/4 pi in addition to that. All right, so here's 3 pi over 4. That's where I'm headed. So I'm just going to land at that angle. And once again, it was sine. So we look at the y coordinate at that angle. And the y coordinate is the square root of 2 over 2. And so that's my answer. All right. Now we're into cotangent, tangent and cotangent. Well, to make tangent, when you find the ordered pair represented by the angle, if you wanted to do tangent, you would do the y coordinate of that angle divided by the x coordinate. Well, then to do cotangent, it's the flip of that. It's going to be the x coordinate divided by the y. Okay, so once again, improper fractions, we're going to change this into mixed. So if you're, again, unfamiliar of how that works, we're just going to divide the bottom number into the top. 3 goes into 4 one time, 1 left over. So it's 1 1/3 pi. Okay, so let's go to our unit circle and do 1 1/3 pi. Erase this. Sorry I'm taking so long. Figured this is the best way to help you if you're still unsure about how the unit circle works, how to look up angles. Okay, so I start here, initial side, positive 1 pi would be there. All right, but I got to go another third. Okay, so 1/3 in addition to this would be to right there. Okay, and you can actually see 4 pi over 3 is the angle that we're looking for. Well, remember cotangent is the x coordinate. I'll just do it on here. The x coordinate divided by the y coordinate. Well, we know it's a negative divided by a negative, which our final answer is going to be a positive. And don't let these complex fractions throw you off. If the denominators match like they do here, you see each fraction has a denominator of 2, then you can just cancel out the 2's. So really, we just have 1 over the square root of 3 that we have to rationalize. And so we end up with the square root of 3 over 3 as our answer. All right. Let's do another one. Cosecant is the reciprocal for sine. So we're going to be looking at the y coordinate when we find this angle. And when we find that y coordinate, we're going to flip it over. So I think I thought we may have had this before, but we didn't. So negative 7 pi over 4 is negative 1 3/4 pi as a mixed number. All right, so let's go back to our unit circle. And let me erase my previous work. And we got to go in a negative direction. Negative 1 pi. All right, so that would be negative 1 pi. And then I'm going to go another 3/4 pi. Okay, so this would be like 1/4. This would be 2/4, which is really a half. And then this would be 3/4. So I'm going to land on this ordered pair. And I'm looking for the reciprocal of sine. That's what cosecant is. So the y coordinate there, which would be sine, is the square root of 2 over 2. But since I want cosecant, I have to flip that over and then rationalize. So I have 2√2 over 2, and these 2's can cancel. So my final answer here for number 12 is going to be the square root of 2. All right. Secant is the reciprocal for cosine. So I'm going to find this angle on our unit circle. I'm going to look at the x coordinate at that angle, and then I'm going to flip that coordinate over because I need secant. All right. All right, so let's do 690 degrees. Okay, so 690 degrees, that's 360 degrees. All right, I went ahead and did the 360, that's a circle. And then I need another 330. So basically I'm going to land right here. Okay, if I did this, I would land right there. And again, it was looking for secant. So I look at the x coordinate there, and then I flip it over. All right, so the x coordinate of that angle at 330 degrees is the square root of 3 over 2. So I'm going to flip that over and then rationalize it. And I end up with 2 square root of 3 over 3. All right, we're almost done. Now let's do negative 240 degrees. And for tangent, when we find that angle, we look at the ordered pair. We're going to take the y coordinate and divide by the x coordinate. All right, so let's take a look at what negative 240 degrees would look like if we were to sketch it. All right, so here's negative 180, and then I have to go another 60. So that would take me up to what looks like on the circle 120 degrees. Okay, and I'm doing tangent, so I take, here's my ordered pair, I take the y coordinate and I divide by the x coordinate. The 2's will cancel, and so I'm just left with I'm left with the square root of 3 over negative 1, which is just negative square root of 3. There's my answer for 14. So important problems, for, your knowledge of the unit circle, how it's made, how it's used. You're going to have 8 problems on your test that are going to be just like that. You can't use calculators for these. So make sure you know how to make the unit circle and use it. Okay, so now we're looking at periods of graphed functions. So a period is the horizontal length of a repeating pattern. So we just have to find out what that repeating pattern looks like in terms of when it begins and when it ends, and then kind of measure how long it takes to finish one of those patterns. So I just typically start at the y-axis, like 0, 0 here. And this pattern goes up, and then it goes down, and then we're back up. And it looks like right here, if you notice, I'm back to kind of like what I would call square one, back on the horizontal starting point. And that pattern now is just going to keep on repeating. And how long is it from start to finish of that pattern? Well, I started at 0, I stopped at 6. So the answer for number 15 is 6. On 16, the pattern, I'm going to just start here. Really doesn't matter where you start. And let's see if we can tell when that pattern stops and then starts again and just keeps on repeating. So the red looks like the continuous repeating pattern. And so a period is how long horizontally is that. So we started at 0, and this is right in the middle of 2 and 4, which is 3. And so my answer is 3. 3 units, whatever, we're not told what the units are. All right, 17. We are converting from degrees to radians, so I'm going to multiply by pi over 180 degrees, and then we're going to reduce. So I can reduce these by 45. So negative 315 divided by 45 is negative 7 pi, and 180 divided by 45 is 4. So I end up with negative 7 pi over 4. Okay, and this is in radians, so I'm going to convert this to degrees. So I want to set it up so that I can cancel pi. And then you just go to your calculator. If you want to reduce ahead of time, you could, but the pi's will cancel. So you're going to do 180 times 9. and then divide by 4. And you get 405 degrees. All right, the arc length of this circle, so we're really looking for this arc length. And the arc length formula is arc length is radius times theta, and theta has to be in radians. All right, so the radius is 15 centimeters, and we're already given theta in radians. We see pi, so that tells us we're in radians. So this is really just a matter of going to our calculator. 15 times 8 times pi. And then divide by 7. And to the nearest tenth, that's going to be 53.9. And whatever the unit of measurement is for the radius, that will be the same for the arc length. So this is in centimeters. All right, number 20, the radius of a child's bike is 12 inches. What's the arc length when the tire rotates 270 degrees? So don't be tricked. The arc length formula has to have theta in terms of radians. So I got to do this little conversion to turn theta into radians. So I can divide both of those by 90. This would be 90 would go into 273 times, and into 180 2 times. All right, so now I can do my arc length is the radius, which is 12, times theta in radians. So let's see, 12 times 3 times pi. And divide by 2. 56 point, it's in hundredths, so 56.55. And let's see, this is in inches. All right. Number 21, sketch each angle, then find its reference angle. So let's take a look. I'll sketch 330 degrees. So this would be 90, 180, 270, and it would be 30 degrees shy, of course, of going all the way around. So I'm going to call that 330 degrees. And so the reference angle is this angle right here that exists between the black, we call that the terminal side, and the x-axis. So that angle is 30 degrees. That's the reference angle. All right. Number 22, I want you to, if you're given radians, I want you to state the reference angle in radians. So in a negative direction, this would be negative pi over 2. This would be negative pi. So it's just about in a negative direction to sketch out this angle. We would go in this direction and it would just be short. This, think of it as this, since this is -1, this is -6/6 pi. Well, we're going to -5/6 pi. Well, -5 pi over 6. And so the angle in here is the reference angle, and that would be pi over 6. Just remember, the reference angle is never negative. Even if this angle is, the reference angle is always between 0 and 90, or if it's in radians, it's between 0 and pi over 2. It's never a negative angle. So the reference angle for number 22 is pi over 6. All right, we're here on number 23, so we're going to do a little sketch. 16, negative 12. 16, negative 12 would put us down here in quadrant 4. I'm going to make a triangle with my right angle being made with the x-axis. I'm going to put theta there by the origin. And so this side of the triangle must be 16. This has to be 12. I'm going to find the hypotenuse. So hypotenuse squared is leg squared plus leg squared. So let's see, the square root of 16 squared plus 12 squared. And that is 20. All right, and now I'm going to find the 6 trig values of theta. So sine of theta is opposite over hypotenuse, but in quadrant 4, remember, the x-coordinate is positive, the y is negative. That means cosine is positive, sine is negative. So it starts off as negative 12 over 20, but I can reduce that. I can divide 4 into each of those. So that would be negative 3 over 5. Okay, cosine of theta. Cosine is positive in quadrant 4. That's adjacent over hypotenuse. And reduced, that would be positive 4 over 5. Tangent of theta is opposite over adjacent. And tangent's negative. And I can reduce here, so that would be negative 3/4. And now I'll just do the reciprocal. So sine's reciprocal is cosecant. So I take sine and flip it over. Cosine's reciprocal is secant. Same thing, I take cosine and flip it over. And tangent reciprocal is cotangent, and I flip over tangent to get cotangent. So there's my final answer for number 23. All right, the next 3, I'm going to test your ability to make a 30, 60, 90 right triangle. So here's how it's constructed. Wherever you put the 30 and the 60 really doesn't matter. But across from the 30 degree, you should put the number 1. The hypotenuse is always double that, so that's going to be 2. And then across from the 60, it's the square root of 3. And then for the 45, 45, 90, of course, these are the same. Their side lengths across from those are the same. They're both 1s. And then the right angle, the hypotenuse, is the square root of 2. So now you can come up with sine of 30, just remembering SOHCAHTOA. Sine of 30, opposite over hypotenuse, that's 1/2. Cotangent 60, well, 60 degrees, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So it started off as this, but then we have to rationalize it, and it becomes the square root of 3 over 3. And then over here, cosine 45, doesn't matter which one of these you look from. Cotangent is adjacent over hypotenuse. But then when you rationalize it, it becomes the square root of 2 over 2. All right, we're almost done. This goes back to lesson 6-8, which we didn't quite get to on our last test. So solving these exponential equations where e is the base, we want to, do 2 things. We're going to eventually change to a log equation, but we've got to isolate e to the x first. So let's get e to the x by itself. I'm going to add 11. I'm going to divide by 4. And now I'm ready to change to a natural log equation. So this would be natural log 7 equals the exponent x. And so now it's pretty easy. We just go to our calculator and we find the ln button, ln, and we put 7 in the parentheses. And to the nearest 10,000th, that's 4 decimal places. So x is going to be 1.9459. Okay, natural log equations need to be changed to exponential, where e is the base. All right, so this is going to be e raised to the 5th power, and that's going to equal 4x minus 1. Okay, so go to your calculator. This time you're going to find ln and do second ln. You see where e is waiting for an exponent. You're going to put in 5, and I would just hit enter. So your calculator should say 148.4131 and so on. Let's do plus 1 because we're going to solve for x. So we're going to add 1. You don't have to write that down. So right now your calculator reads 149.4131,591. And now you got to divide by 4. So let's just use that number in your calculator and do divided by 4. And we get 37.3533 rounded to the 4th decimal place. Okay, inequalities work pretty much the same way. ln, it gets changed to e to the power, okay, just like this one. So e to the 2nd, but just keep in mind, since the inequality is pointing at 2 in the original problem, it still should be pointing at 2 when I rewrite it. So pretty easy. I'm going to do e to the x, and then I'm going to put in 2 as the exponent, equals, and then I just subtract 1 from that. And that's my answer, 6.3891. And that number is less than x. Or if you prefer, like me, you could say x is greater than 6.3891. You can do it either way. And once again, just like number 27, we got to get e to the x by itself. So we're going to subtract 2. And now I'm going to change it to a natural log equation. So natural log 7 is equal to x. Okay, looks pretty much just like our other one. And so it's that same number, 1.9459 should be less than. I'm sorry, greater than. Notice when we had e to the x is less than 7, the inequality is pointing at x there, so it still should be pointing at x. So 1.9459 is greater than x, or you could say x is less than. All right, and that concludes the test prep. Your test will have 30 problems that will look very much like these, so I hope this helps you in your preparation. If not, come and see me, and I'll be glad to help you. I'll see you next time.